Hello everyone, welcome back to another video for the series. I'm Q and today I brought a really interesting poem from Ireland, and yes, I kind of love this problem. So although the structure of the solution I'm going to share right now is the same as the official solution, I think the slight details are quite different. So yeah, please keep that in mind. And then let's start. Suppose A, B, C are real numbers such that these are true. Prove that and determine the case of equality. Okay, so first of all, we know that uh, let's just say that we know that C is equal to negative A plus B by our first equation. Therefore, A squared plus B squared plus C squared, we could rewrite it as A squared plus B squared plus A squared plus AB plus 2AB plus B squared. This is equal to 2 times A squared plus AB plus B squared, and this is equal to 1. Now therefore, A squared plus AB plus B squared equals 1. Now here's a part where I was really surprised, because I didn't know that they will use AMGM inequality here. So normally when we think of AMGM and 3 variables, I would have used 3 variables, but then we'll notice that so I think, wait, does it work? AB plus B squared. Yeah. So for me, I would have used this one and get this. Oh, sorry, it's 1/2. Wait, we could actually use this. Never mind. Let's just do it. Yeah, so in the official solution, they use these two and then added. So like we get AB plus 2AB. So we get 3AB. So you get, yeah, I'll just write it. We know that A squared plus AB plus B squared is greater than or equal to, by AMGM inequality, AB plus 2AB, we can use these two, and this is equal to 3AB. This is what the official solution did, but for me, I think I would have just did this one. Oh wait, but this doesn't work. No, this works. 3AB. But we have to assuming that A and B are positive numbers. But I don't think this thing really matters, because anyways there should be a positive number here, and yeah, I'll get more into this later after solving it. So we know that AB, because this is 1/2, AB is less than or equal to 1/6. Now, what is, therefore, A squared B squared is less than or equal to 1/36. Now let's take a look at C squared. Equals A squared plus 2AB plus B squared. This is equal to 1/2 plus AB. And equality, when A equals B. And this is less than or equal to 1/2 plus 1/6, which is equal to 2/3. same equality and A equals B. Therefore, multiplying them, we know that A squared B squared C squared is less than or equal to 18 times 3, which is 54. And that proves our inequality. And when A equals B, let's say when A equals B, A equals 1 over root 6, B equals 1 over root 6, C equals negative 2 over root 6. Let's see if this works. 1 over 6, 1 over 6. 4 over 6, that satisfies these two equations. And 1 over 6 times 1 over 6 times 4 over 6 is equal to indeed, it is 1 over 54. Yes. Now we are almost done because we have to justify that we could actually do this. So our first case is when we have without loss of generality, A and B both positive and C negative. And we prove this. Second one is without loss of generality. So the reason why I'm writing without loss of generality here is because I want to mention that we're just counting the number of positive ones. When A and B are negative and C is a positive. Okay. For this one, what we're going to do right now is just flip the signs of ones that already satisfy this one. Then I'm not going to write it reverse here because we already completed our proof. We proved it. So let's say there is A prime, B prime, and C prime that satisfies the equation above. Then let's flip it. Where A equals a negative A prime, B equals negative B prime, and C equals negative C prime. Now, we know that A plus B plus C equals 0 because when we add them, it's 0. A squared plus B squared plus C squared is indeed 1 because A prime squared plus B prime squared plus C prime squared equals 1. And because, notice that, because this is true, we already proved it here. We know that negative A prime squared, negative B prime squared, negative C prime squared is less than or equal to 54. Therefore, A squared, B squared, C squared is less than or equal to negative 1 over 54. And the equality condition is the same because we are anyways going to square it. Now, the third case is when we have 1, 0. Let's say A equals 0, B is a positive number, C is the negative number. Then we know that B equals negative C. This should be B equals negative C, and B equals 1 over 2 because 1 over root 2. And this obviously satisfies this one because 0 is less than or equal to 1 over 54. So we actually took a look at every cases and we know that this proof works because we could actually manipulate our first proof. We can actually use the conclusion from our first proof to take a look at other conditions like this. So yeah, that's the problem. I think the kick is trying to rearrange the terms AMGM and Yeah, here for me, I quite struggled a bit because I was not able to think of this case for some reason. Because I just wanted to continue from a plus b here, and then like somehow square it later with the conclusion, but that didn't work out. But this one, it does work, so it was quite interesting. Yeah, then thank you so much for watching this video, and tomorrow I'll come back with another very fun and interesting problem. Thank you, and see you tomorrow. Bye.